Hello, I welcome you all. The problem reads that the skier starts from rest at A and travels down the ramp. If friction and air resistance can be neglected, determine his speed at B when he reaches B, of course. Also compute the distance S to where he strikes the ground at C. Right, if he makes the jump traveling horizontally at B, neglect the skier's size. He has a mass of 17 kg. Alright, okay. So we are being asked here to determine the speed at speed VB and later on the distance S. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by RC Benam. So for me, I'm going to use, of course, there are a lot of ways to solve this. One of the ways is, of course, using the conservation of energy, okay, principle. So I'll use the conservation of energy principle from A to B, find VB, later on calculate S. So let me determine what these distances are from this point to there in advance to S, like so. I'll need this. I determine this, okay. And this, I'll choose which one to use. What else? Right, let me just clean it up. I just clean it up like so. Okay, there we go. Okay, there we go, like so. So we are going to call this distance here, because this one here is 30, right? Therefore this is just going to be equal to, this is S sine 30, okay, and this is S cos 30, right? Great. So we have the weight of the skier. Let's say the center of gravity is somewhere there. All right, and then we have normal force, like so. Okay, so this is W and this is the normal force. So let's apply the conservation of energy from A to B. So say the kinetic energy TA plus the potential energy VA is just equal to kinetic energy at B plus the potential energy at P. So T, like we said, this is the kinetic energy, and V is the potential energy. We have gravitational potential energy and elastic potential energy. So what is TA? TA, the skier is starting from rest, therefore this is equal to 0. And what is VAG? VAG, I'll need to determine the datum first. Let me say I choose this to be my datum. I choose this to be my datum. Alright, so this is my datum. Again, you can choose whichever point. I can choose the bottom, I can choose the top at a point. So this is my datum. If that is my datum, therefore my VAG, gravitational potential energy at A, is just 0, and my elastic in this case also is 0. Then TB at B, I will have kinetic energy, that's half VB squared, and then my VBG at this point is just going to be minus WHB. Okay, which is where HB is just equal to 50 minus 4, right? 50 minus 4. Right, and is equal to 46. Alright, and then we have VBE, this is just equal to 0. Let's rewrite the whole equation. I'll not include the zeros, so just include just 1 0 if there's nothing else, so just be 0 is equal to half MVB squared minus WHB. Right, let's add some numbers there. Half, our M is 70. We don't know what VB is, so it will just be like that. And then the weight, just 70 by 9.81. Okay, times HB, which is just 46. Therefore, our VB is just equal to our VB is equal to, let's calculate it. That is 70 times 9.81 by 46 divided by 0.5 by 17. The square root of that, we have a 30.04. Okay, this is meters per second. Let's work it out again. 70 by 9.81 by 46 divided by 0.5 by 17, and then square root of that, 30.04. Right. Okay, so let's take this as our reference. So let's now find S. Okay, so we use this equation. Remember this equation. Our acceleration is constant, acceleration due to gravity. So we can use this equation. So let's start with vertical motion. Alright, vertical motion, what do we have? S is equal to 0. Then S naught is equal to 4 plus S sine 30, and then AC is just equal to minus 9.81. What else? V naught is equal to 0, because this one is horizontal. In the vertical direction we don't have anything. So we'll have 0 is just equal to 4 plus S sine 30. Okay, and then minus half 9.81 by t squared. Okay, right. Then this is one equation. Let's find the other equation. S is equal to S naught V naught t half ACT squared. Then say horizontal motion, right? And here our S is just going to be equal to S cos 30. Our S naught is equal to 0. AC is equal to 0. And V naught is just equal to VB, which is just equal to 30.04. Therefore, we'll have S cos 30 is equal to V naught, like so, times T. So we do have two equations now. What we just need to do now is to solve these equations. Okay, so let's say this is one equation. This is the second equation. course, there are several ways of solving this. Let's replace our s there. We make s subject to formula, so we'll have s3 like so, t divided by cos 30. So let's replace this here. We replace this here. When we do so, then we'll have the following as 0.5 by 9.81. So here we'll have a minus 4.905 t squared. Then we'll say plus 30.04 divided by cos 30 or times tan 30. Okay, so this will be a 17.34 t. Okay, then plus 4 equal to 0. So in solving this, we are going to use a quadratic formula. So we'll have t equal to minus b, which is a 17.34 plus and minus 17.34 squared minus 4a minus 4.905 by 4ac divided by 2 by 4 by 2a. Alright, so let's work out this. There we go. Divide that like so, like so. Okay, and therefore our t is just equal to 17.34 squared plus 4 by 4.905 by 4 square root. Alright, there we go, divided by that. Of course, our t is just equal to 3.75. Okay, so s, therefore, we said s is just equal to 30.04 t, which is 3.75. Okay, divided by cos 30. So s is just equal to 30.04 times 3.75 divided by cos 30. This we get a 130.08 seconds. Okay, I think this is about it. We have found the value of s. As well as the velocity vb, and also the time it takes to move from this time here. This is time takes to move BC. Okay, I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.